In this video, we want to evaluate the integral of 2 sine of x over sine of x plus cosine of x. Now, this is very similar to another integral we did in a previous video, where we basically multiply the integral by 1 and then what amounted to adding 0 to the integrand. I'll put a link to that video in the description. Letting u equal to the denominator, not going to work. Or letting u equal to sine of x or cosine of x. You can try that, but it doesn't work. You want to pause the video now and try it? Go ahead. I'll be right back. Okay, so this is what I'm going to do. Similar to what we did in, like I said, in the previous video. Eventually, I am going to use a u-substitution equal to what's in the denominator. But I first kind of have to set this up so it works. Manipulate the integrand. So like I said, I know the derivative of sine is cosine, derivative of cosine is minus sine. So I got 2 sine here. So here's what I do. I'm going to put a sine of x plus cosine of x. And notice as it stands there, sine of x plus cosine of x over sine of x plus cosine of x is 1. So that makes the integration pretty straightforward. But then I'm going to go a little further here. I have 2 of these sines, so I'm going to put another one over here. So 1 and 1 is 2 sine x, so that's the same. And then I put an extra cosine here. And I can do that as long as I subtract it. So I'm basically adding 0. That's cosine of x dx. Just again, double check. We haven't changed the original integral. Oh, yes, 1 sine, another sine over here. That's 2 sine. Cosine x minus cosine x cancels. So this is the same thing as what we started off with. Okay, so now this is going to equal 2. Now what I'm going to do is I'm going to break this up into 2 integrals. So the first one is going to be sine of x again. Haven't changed anything yet, just changing the form. So like I said, this one is just going to give us, if I divide this out, this is just going to give us the integral of 1 dx. So that's no problem. And then I'm going to have a second integral. It's going to be over here, the sine x minus cosine of x dx, and that's going to be over sine of x plus cosine of x. Now, like I said, the derivative of, and this would be a plus here. Notice we still have the same thing. Sine and sine is 2 sine, cosine and minus cosine cancel, so we still start off with the, wind up with the original integral. Now I'm going to let u for the second integral, because the first one's very easy. But for the second integral, I'm going to let u equal to sine of x plus cosine of x. Then du is equal to the derivative of this. Derivative of sine is cosine. Derivative of cosine is minus sine. And this would be dx here. Okay, the only thing I need now is I need these signs to be reversed. You look at the substitution over there. I need a positive cosine and a minus sign. So I got a plus right here. So what we do is just factor out a negative. Factor out a negative here. Put this minus out in front. And now what we have to do is change this positive here to a minus and this to a plus. So now we have this now is okay. So now for this one here then, this is going to equal to, this just cancels out. This will be the integral of 1 dx, which is just going to be x when we take the integral of that. And then here This is minus the integral. So this will be u here, and this part in the numerator, is going to be du. So this will be minus, and this will be du over u. Now we just integrate. So the integral 1 with respect to x, let's get it with respect to x, that's x. And then this is going to be minus natural log of absolute u. Okay, that's just the formula for the integral of 1 over u with respect to u. But u is sine x plus cosine plus your constant of integration. So the final answer is right here. X minus natural log of absolute value of sine x plus cosine x plus your constant of integration. And that's it. Very similar to the other one. I think the other one was a little bit more tricky than this one here. And I'll put a link to that one in the description in case you missed it. Thanks for watching. We'll see you next time.